Alright, ladies and gentlemen, this is an example of the plan sheet that you'll be using to do your practical. This one is specifically for option 1, which is the furniture construction or woods, and this is how it goes as follows. In this section, you'll fill out the relevant information like your name, the territory, which is Jamaica, school, then high school, and all the other information which you already know what is. The proficiency is technical, right? Now in this section, what they're asking you for is a drawing, a isometric drawing of the object that you made. The object that you made would have been the cupboard, and so that is where you place it, right? In this section, the cupboard, I'll demonstrate from a simple example. So as soon as you have had the chance to do your soft copy, your drawing of the cupboard, whether by hand or by digital software, whichever software you choose, then you would make a picture of it and save it here. And that shows a 3D view of what you had made. On your second page, they're asking you now to show the orthographic view, which should look something like this. So once you're done with your drawing, take a picture of it, save it, and place it within your document. Try and use up as much of the space as possible on each page. So that was page 1 and page 2. Page 1 isometric, page 2 orthographic. Page 3 requires steps and procedures required to make the object. So a summary of what we did in order to make the object was to step 1, put pieces for frame. Step 2 was to mark out joints, and we use lap joints and mortise and tenon joints. After cutting all pieces and creating our joints, we assembled using a drawing technique. After assembly, plane the frame for squareness. Cut and install side panels. Cut and install back, base, and partition. Assemble. Door using mortise and tenon technique or joints. And so you have an idea now of what the whole thing is going to be like. From this stage you would have probably do some sanding, filling. That's when you use the dowels to plug the screw holes, and doweling would be part of the assembly. So let us say we assemble using gluing techniques, and after gluing them together and screwing them together, there would have been a lot of holes left back in the cupboard, so you'd have covered those holes with dowels. And so that's what would be the next step: to fill, dowel, sand, and the final step now would be to apply sealer, sanding, and then varnish again as your finished product. On this side of the table, you are required to list all tools that you were required, or all tools that you use to construct the cupboard at each stage. So for example, for the measuring and cutting of the pieces in order to construct the frame, you'd have needed tape measure as a tool. We use the table saw mostly to cut all the 2x4s. We use the circular saw, and also the miter saw, mainly to do all the cutting. At some point, to mark out all the lap joints, we use a jigsaw for a section, along with a lot of chiseling, and of course to strike the chisel you would need mallet. This is just to give an example of all the things that you are going to need. This is merely this is probably less than half of all the tools that we had to use throughout the process, and half of the steps that are required to construct the entire thing. But this should be able to give you a suitable start. Last example that I look into is the assembly section. When we were assembling the frame, I'll go back to the frame view. When we were assembling the frame, you had to use a list of tools. To get these parts together, we use the power drill along with screws, wood glue, sash clamp, mallet, and a long list of tools. So all you have to do is now go back to the plan sheet, find that section for assembly, and state that you'd use wood glue, bar clamps, hold fast clamps, G clamps, use a power drill, or let's just say a screw gun. A lot of screws of various size and so forth. So just fill out that section. Try not to leave out any of the steps. And as for page 4 now asks for a breakdown of the materials that you use. This is more specific to materials. For example, going back to the plan of the frame, looking at the frame, you basically count the number of pieces that are involved in this frame. For example, for this side, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so you'd go back to your plan shape and have 14 pieces. Name of the piece or name of part, frame, and in brackets you may need to state that the frame was constructed from 2x4 board. Sizes. Now the sizes may vary. Let's see now, TWL thickness would have been 2, length, width would have been 4, and length now would have been quite a lot of, well, that number would be depending on the amount of pieces that you use. For example, the length here is 72 inches, so that's 72 there by 24 by 72 by 24. If you add those numbers up and add also 36 down, 36 down, 36 and 36, and then from the base frame add 72 again, 24, 72 and 24 again, and for these two middle sections 28 and 28. Add all those numbers up, and that is the total length that is required for the frame. So that's 2x4 by the appropriate length. You will have to add those up. For material, use pine. Pine board. The measure would be a multiplication of 14 plus this number. So let us give you an example then. 2x4 by 350. 2 times 4 would be 8, and 8 times 250. With 2,800. So basically use 2,800 square inches of pine just for the frame alone. Unit price, you may not know the unit price, you'll use a figure of your choice. Let us say $20 per square inch, for example. So that would be 20 times 2,800. That's what, $5,600 worth of pine board for the frame. After putting on the frame, you would have added the side panels and partitions. So that's 24 by 36, 24 by 36 and 24 by 36. Just fill those numbers in to the table. 24 by 36. How many pieces of that? That's 3. One to the left, one to the right, and one in the middle for the partition. And let's just call these panels, in bracket, sides and partition, or let us say sides. Let's leave it by the sides for now. And so that will be only 2 pieces. So 2 pieces for the side, 1 piece for the partition, and the partition has the same size of 24 by 36. 24 times 36, 864. and you needed 2 pieces of that. So that's 864 times 2, 1728. What did we use? Um, half-inch construction ply. Unit cost, that is about a full length of, that's a full sheet, I should say. A full sheet is about $5,000, and divided by 1728, let's just say it's basically $2 per square inch, and so it add up to about $5,000. Well, $2 per square inch, when you multiply it, about $5,000. This one would be the same, $2 per square inch and half that amount. And for the partition, you did use plyboard, and so that's about $2,500, and the list goes on. So from the frame, side panels, partition, next comes the backing and base. Also, there was a shelf in the middle. From after that, there was a top that you had constructed, glued together from 2 by 12 boards. So for the top section, it would have been made from 2 by 12. And how much of it did you use? Say about 750 for example's sake, and you multiply this number to get the answer. So follow this table based on all the things that you had done. The group that you were working with, you can complete the plan sheet in groups and then share information so that each member from that group may have a copy of the plan sheet. So for example, all the persons that made the panel, like for example Oculus group or Fagan's group, all the persons from that group can work together, share information, create the plan sheet, and then you create your individual copies to send individually. Must receive a response from each person to be able to write down a grade for you. Any further questions, you have my email.